All right, for part two, again, we have the wall here. This time we have a boom that is not coming out perpendicular. That's going to make it harder. The boom's coming up like this, and then we have a chain coming like this, and this angle in here is 80 degrees, and this angle in here is 60 degrees. Okay, and we have a weight still hanging down here of, I'm going to make the weight go down further, of 1960. And it says the boom also has weight, and that's going to be right in the middle. So the boom is also going, straight down, and it's 1220. Okay, and we're trying to find what's the force in this chain right here, and what is the forces working on the boom. Now this one is a little trickier because remember, there's always a force going directly onto the boom. So technically there's a force going, like this, straight into the boom. But there's also this force here that would be working kind of, like up. There's going to be a force kind of going up like this and then straight into the boom, so I can get my eventual force there. Okay, and we'll redraw that here in a second to show you. Okay. So what do I do here? Well, this is really rough. The boom is what we want to think of as our x-axis. So we have a force pulling, like at an angle, and we have a force pulling at an angle here and a force pulling at an angle here. By the way, what are these angles here? Well, if this is 60 degrees, then these are also 60 degrees, right? Okay, but what I want to do here is I want to resolve these into things that are going perpendicular to the boom and things that are going parallel to the boom. So the way I always do these problems here is I always say, okay, look at your boom. It comes out like this, and put a capital T on that to make it a capital T. So I'm going to put a thing here, a line here that's perpendicular to the end of this thing, so it looks like a capital T if you can see it there. Okay. So this is, I'm going to have this go all the way up like this and have this come down like this. I'm always going to just draw a capital T onto that boom, because that'll help me kind of see how I need to have my forces. So this is going to go up like this, and then it's going to come like this, parallel to this boom. That's parallel to the boom, and this will be 90 degrees because this is perpendicular and that one's parallel. And then I can do it down here too. See, I can do right here, and I can go like this and do a perpendicular and a parallel. Okay, now the same thing has to happen here. This is going to be something going down like this and then parallel. And if these are 60 degrees, then these angles in here, which is the ones I want, would be 30 degrees. Okay, and this is 80 right here, then this is going to be, that's 10 degrees in there. Okay, so it's very similar to the last problem, except for we have to resolve, not only do we resolve this chain, but we got to resolve these two weights also into perpendiculars and parallels. And we need to figure out what they all are. So we can do that down here first. We can't do that up here because we don't know anything about this whole triangle except for the angle. But here we have a hypotenuse and we have the angle. So I can figure out these two sides down here. So this side down here would be 1220 times the sine of 30, 1220 times 30 sine, which would actually be half of 1220, so it'd be 610, okay? And then also 1220 times 30 cosine, and this is 1057, so 1057. And then this is 1960 times 30 sine, and this is 980. And this is 1960 times 30 cosine, and this is 1697. Okay, that's all we can figure out right now. And so now we get to the point that we did in the other problem where you're going to come down here, and this is going to be your frame of reference, and we're going to measure torques along this boom this way. And don't worry that it's an angle. If you need to, shift the whole thing so it looks like that or something. So. Okay, that's why these problems are hard. You always have to tilt your head to do them. Okay, so I'm going to go halfway out times 1057. Remember, this is the only one I'm interested in here. halfway out, 0.5 times 1057 plus 1 times this, 1697, should equal 1 times this force right here. So that force should be 0.5 times 1057 plus 1697. This force up here should be 2225.5. Okay. Now remember, when we get that, a lot of things fall into place. So since I have now an angle and a side, I can figure out this side over here. So the tangent of 10 would equal opposite over 2225.5. So 2225.5 times 10 tangent equals, and this up here is 392.4. Now I got these two sides, so I can use Pythagorean's theorem. Plus 2225.5 squared, square root. And the chain in here is basically 2260. So I'll write that over here. Got the chain figured out. That's always the first problem. 2260 newtons. Okay, now I need the boom. Okay, so what do we got here? Well, we know that we should have a force pushing directly into the boom and a force going up like this that would balance out all these ups and downs. So I could figure out what this force is, like right there. Okay, so I'm going to do ups and downs, and I'm going to do lefts and rights. And you know, that's the thing. And these are not technically ups and downs. They are up and down compared to my x-axis, which is the boom. So I have an up here of 2225.5. I have a down of 1697. I have a down of 1057. For lefts and rights, I have a left up here, 392.4. But I have a left right down here of 610. And I have a left here of 980. See, there's a lot. So if I add those up, 392.4 plus 610 plus 980, those are all my lefts. And so I need a right of 1982.4. So right here, I'm going to do 1982.4. This force here is going to balance out this one, and this one. Hopefully that makes sense. So my ups and downs, I have a 1697 plus 1057 is my total downs, minus 2225.5, and I should have an up of 528.5 is that up. And so over here, I can do Pythagorean's theorem, squared plus 1982.4 squared equals square root, and the boom is 2052 newtons. And now I just need this angle here below the boom extended, and that would be tangent of the angle equals 528.5 over 1982.4. So 528.5 divided by 1982.4, shift tangent, and it's 15 degrees. So at 15 degrees, and there's my total answer for this nasty boom chain problem. Chain is 2260 newtons. I hope those are all right. And the boom is 2052 newtons at 15 degrees. And yep, I just checked the answer and they're all correct. So that's how you do the second boom chain problem. It's a little tougher.